Hey, time for analyze math and history, and we are going to take a look at the quadratics on a graph. So we've been looking a lot about the absolute value, how to solve for x, the function y equals mx plus b, and we've been seeing what they look like on a graph. But we're going to take a look at a new kind of graph, quadratics on a graph. So to start off, simple, what we're going to try and do is try to graph whatever this equation is. The function of x equals x squared. So how are we going to do that? Well, let's try to plug in some kind of numbers that we well know of. Well, since from the last video, we've been doing a lot of like -2, -1, 0, 1, and 2. Those were test numbers to help us understand absolute value. But for quadratics, let's see what happens. The rule of the game is whatever you put in for x will become what y is to help us understand why quadratics is different. So -2 squared is going to be +4 because a negative times a negative is a positive. When you have two negative numbers, they become a positive number. -1 times -1 is going to be +1. 0 times 0 is 0, a neutral number. 1 times 1 is 1. And 2 times 2 is 4. So let's try and see what happens when we try to graph it out. When you saw the graph on the computer, you realized it looked something like this. It's not a perfect drawing, but it does look like something like that. It's a U shape, and that's what a quadratic is. It's a graph that has a U shape that goes up 2 times or down 2 times. And not only that, if you try the vertical line test, yes, it's a function. So what we're going to try and do is understand how to graph a quadratic. And in the next problem, it's going to be a little bit harder, but we're going to do the same kind of drill. So, turns out that this is going to be our next problem, which looks a little bit more difficult, because it tells us to graph the function of gx equals parentheses x minus 4 squared plus 2. How are we going to graph it out? And what are these things anyway? What's the domain, range, and the vertex? Well, let's start off simple again. We're going to do what we did in the last problem. If we tried out x squared, we get x and y. -2, -1, 0, 1, 2. And we get +4, 1, 0, 1, and 4. So that's going to be a ratio table if we try to use x squared as a model. But how is that going to affect the equation way over here? Well, if you remember from a few videos ago, that formula or that equation is kind of like this, where the A helps you reflect and scale, the C helps you move right or left, and the D helps you move up or down. And turns out that this equation is actually a set of directions. So what this assignment is trying to say is, if I try to transfer this and use that equation to move it somewhere else on the graph, what is that graph going to look like? So we have used this as a model, but let's try to see what happens when we try to use this equation right up there. So we have our x, and we also have our y, but the question is, why am I keeping them even farther apart from each other? Well, here is what's going to happen. That equation we just saw is actually a set of directions, like we said earlier. So the C is going to be here, and the D is right there. So let's try and take a look at for x, or the domain. So the x is going to be, subtract that, and actually add that by 4. Because when you are using this, when you add and subtract, you will get a subtraction symbol. So that's why it's a subtraction symbol right over there. So if you do x plus 4. So let's see what happens. Negative 2 plus 4 is going to be positive 2. Negative 1 plus 4 is going to be positive 3. 0, 4, 4. 4, 1, 5. 4, 2, 6. So it should look like this for the x. But what about the y? We have nothing over here, which generally you would have an a, but in this scenario we don't have an a. Or we don't have a. What about the d, which is the number 2, which helps the graph want to move up or down? So how are we going to do that? Y plus 2. So insert your old y into your new y. So we have 4 plus 2 is 6. We have 1 plus 2 is 3. We have 0 plus 2 is 2. We have 1 plus 2 is 3. And finally, 4 plus 2 is 6. So if you ever try to graph this on right here, then it's going to help you understand what the parabola might look like, or what the quadratic might look like. Oh, and yeah, a parabola is the shape of what this thingy is called when you graph it on a graph. So let's see what happens when we try to graph it out. So it looks like the graph makes it want to look like this. I know it's not the perfect one on a piece of paper, but it's to the best of my ability. So that's what the parabola will look like when we try to move from this all the way to this. When we transfer all that data from here to here, and that's what we get right here. But we're not even done yet. What's the domain, range, and a vertex? Well, the domain is all the possible values of x. So how are we going to do that? Well, looks like the graph is going to go from point to point with arrows. Meaning that's going to go infinitely this way to the left and infinitely this way to the right. So here's what's going to be our domain. Negative infinity, comma, infinity. And we have to add parentheses because infinity is not an actual number because it doesn't really actually have a set value. Like 1, 4, 8, 7, 2, 4, 6, 8. Who do we appreciate? Those are all numbers with a set value. Infinity does not because it's supposed to represent some kind of strange number that goes on forever and ever and ever. What about the range? Well, the range talks about all the possible y values. And it goes up and down. So it turns out the range will start here and it will not stop. So how are we going to do the range? Well, on the thing, on the graph, it kind of looked like that the range was at 2. So we're going to put 2 right here and make a comma. But it keeps infinitely going up, up, up. Which means we are going to have infinity. But uh-oh, since 2 is a number that has a set value and it doesn't change, instead of a parentheses like infinity, we must keep it as a bracket. But hang on, what about the vertex? Well, the vertex is actually very, very important because that's what actually starts to have the point right over here. And if you realize, you can actually see the vertex right in front of you by seeing this equation right above. The vertex is always going to be the opposite of the operator right over there. But also, it's going to be the number 2 right over there. Meaning that our vertex is going to be 4, comma 2. So that is going to be our vertex. You could actually write the vertex before you actually start doing all this stuff with the calculations. Wait, before we end this video, there is something that your teacher might put on your test if you're in some kind of strange math class. A minimum or a maximum, and the x-axis? Well, how are we going to do that? Well, we kind of already explained it with the domain and the range. When you talk about the min or the maximum, we're going to actually use the range in this one. If you take a look at the picture right over here, looks like we have a minimum, but we don't have a maximum because it keeps going forever and ever and ever. So meaning we will have a minimum, and our minimum is going to have a number of 2. So that is going to be our minimum, which is going to be on the y right over here. This is the 2 value. We can also use that for the vertex. But what about the x-axis? How are we going to measure that? Well, for the x-axis, that's going to talk about where does the x lay at on the vertex. So if you cut the thing in half, which is symmetrical, meaning 2 things look alike on each side. Then it means that it's going to be the x-axis of where the vertex meet. So if you look over here, the vertex can actually help us and cheat it all out. So 4x equals 4 is going to be our x-axis. So that is going to be the 2 extra problems or the 2 extra things that your math teacher might want you to know for your next math test. I hope this video has helped you understand quadratics on a graph. Thank you for watching California Lines Math Industry. Like and subscribe.